Hi, welcome everyone. In this video, I am going to explain you the detailed answers of the BMAT chemistry questions of 2020. So let's start. So the first question, a sample of an element consists of two isotopes. The relative abundance of each isotope is shown in the table. So you know that to calculate the abundance, you need the mass number exactly. So here they have given you number of protons, number of neutrons and number of electrons and their relative abundance. So isotope 1 31, 38 and 31 60 percentage. Isotope 2 31, 40, 31 and 40 percentage. What is the relative atomic mass of the element in this sample? 31, 38.8, 39, 62, 69.8, 70. So let's see. So first of all, the isotope 1, this is the number of proton and neutron to get the mass number. So if you are adding, that is 31 plus 38, that is 69, and its abundance is 60 percentage. If you want, you can take 60 divided by 100 whole, okay, because that is a percentage, plus the next one is 31 plus 40, that's going to be the mass number. 31 plus 40 is 71 multiplied by 40 percentage. So understand the value. The abundance is 60 percentage for 69. So the value is more nearly to 69, not more nearly to 71. That is the first point you should understand. So it's neither 31, 38.8, 31, 62. It's either 69.8 or 70. So from this option it is very clear that 69.8 is more nearer value to the 69 compared to the 71, because another one is 71. So we don't want an answer near to 71, we need an answer near to 69. That is going to be 69.8. Even if you are calculating, you will be getting the answer 69.8 as the mass of this isotope. Relative abundance of each isotope is given. From that we are going to calculate its relative atomic mass. So simply multiply the mass number with its relative abundance percentage plus the second one divided by the whole 100. Then you are getting 69.8. Next question, how concentrated aqueous sodium hydroxide and chlorine reacts as shown in the equation? 6 NaOH plus 3 Cl2 plus 5 NaCl plus NaClO3 plus 3H2. Which of the following statements are correct? Chlorine has an oxidation state plus 5 in NaClO3. So if you are considering NaClO3, Na is a metal, you know that its oxidation state is plus 1. Oxygen is minus 2, 3 times minus 2 is minus 6. So the first one is plus 1, 1 plus x plus 3 times minus 2, the whole should be 0. So the x is going to be uh, x is going to be minus 6 plus 1, that is plus 5. So that statement is correct. Cl is having the oxidation state of plus 5 in NaClO3. This is an example of a disproportionation reaction. Disproportionation reaction means you know that a same element is undergoing both oxidation and reduction. The left hand side, if you're observing this chlorine, it's in its stable form. Chlorine molecule is having an oxidation number 0. Right hand side in NaCl, the Cl is becoming a chloride ion and its oxidation number is minus 1. In NaClO3 we discussed that is plus 5. So if you are observing, chlorine oxidation number decreased to minus 1, that is reduction, and it increased to plus 5 from 0 to 5. So the chlorine is undergoing oxidation as well as reduction. That is why it is an example of a disproportionation reaction. Some of the oxygen in the hydroxide ion is oxidized. Oxygen is minus 2 only in everywhere it is minus 2. So it is neither undergoing oxidation nor reduction. The answer is 1 and 2 only. The next question, the reaction between hydrogen and nitrogen in the presence of an iron catalyst is known as the hybrid process. It is reversible. So first of all understand the reaction is nitrogen and hydrogen gas. They are reversibly giving you NH3. If you are balancing, it's going to be N2 plus 3H2 will give you 2NH3. So if you're observing this diagram, it is between energy and progress of reaction. So this is the reactant area and this is the product area. Okay, and they're asking you what is the energy change when 1 mole of ammonia is decomposed into its component elements. So basically, understand they're asking you the reversible part of the question for 1 mole of ammonia, not 2 mole of ammonia. Here in the balanced equation, it is 2 mole, not 1 mole. So whatever the answer that you are having, you should divide that with divided by 2. So if you're observing the reactants here, the reactants 3H2 and N2 having an activation energy of 206, it is the activation energy, and you're getting the product by releasing 92 kilojoule, that is negative 92 kilojoule, the enthalpy change is negative. Now you might have a question, what is this plus 298? This is the activation energy for the reversible reaction, but they are asking you how much heat required to decompose the 2NH3. So simply for making 2NH3 it released minus 92 kilojoule. So for coming back, for making it reversible, you need plus 92 divided by 2, that is going to be 46 kilojoule. And of course this is a decomposition, I mean you are dissociating NH3, so it will absorb the heat, that is why it is plus symbol not minus symbol, so it is 46 kilojoule absorbed. Enthalpy change or the energy is going to be, the heat energy is going to be positive in this case. Next question. A gold medal is used in events such as the Olympic Games is made from a silver nickel alloy with a coating of gold silver alloy. The mass of the medal is 256 gram. The entire mass of the medal is 256 gram, of which 24 gram is the mass of the coating. 24 gram is the mass of the coating. So understand, 24 gram is the coating. That means coating is gold silver alloy. Gold silver alloy. And the remaining is 256 minus 24. That is going to be 232, that is 232 gram of silver nickel alloy. Alright, the density of the silver nickel alloy is 10 gram per centimeter cube and the density of the gold silver alloy is 16 gram centimeter cube inverse. You know that density equals mass over volume. They are asking you volume of the metal totally. So volume equals to mass over density. So for the first one, mass is 24 gram. So divide 24 with its mass, sorry, its density given for the 24 is 24 grams for the coating. Coating is gold silver, that is 16 grams centimeter cube inverse. So you should divide by 16. This 23, not 23, 232 actually, 232 gram. This is 232 gram. 232 gram. 232 gram you can divide with 10 gram. 10 gram centimeter cube inverse, that is the density. So this is going to be 23.2 volume, and this is going to be, if you are cancelling with 8, 3 times 8, this is 2 times 8, so 3 by 2 is 1.5. So if you are adding 1.5 plus 23.2, that is going to be 24.7. 23.2 plus 1.5, that is going to be 20.47 centimeter cube in terms of volume, because we are calculating the volume in centimeter cube, that's why it is in centimeter cube. Next question, it's related to the reactivity of metal, so you should read these sentences or these points or postulates very carefully. We're having four metals R, T, X and Z, and we have some statements like R fizzes when added to dilute hydrochloric acid. Basically, R is a metal. Whenever you're adding to dilute hydrochloric acid, its fizzing means it might be a carbonate of the metal basically. T is precipitated. T is precipitated whenever you are reacting R in the solution of aqueous. T with some aqueous, maybe chloride or something. We don't know what's that. Simply I'm taking X, aqueous. So you are getting the T precipitate plus the R with that X. Again, I mean X, we cannot say exactly. It can be anything. So the R is displacing T means that is why you are getting the precipitate of T. So you can say R is more reactive than T. R is more reactive than T. That's the first statement you can understand from that second. X is the only one of these metals that occur naturally on Earth uncombined with other elements like gold and gold is like least reactive, that is why it is available in the earth crust in the uncombined format. So that is going to be the least reactive. So X is the least reactive. Least reactive. Now you are having only Z. Z is the only one of these metals manufactured commercially by electrolysis of one of its molten compound. Maybe like NaCl or something. NaCl, you know, that is like highly reactive. So NaCl, if you are electrolyzing, you will be getting sodium metal and chlorine gas. But R and T you cannot do by electrolysis. You have to go for R and T can be manufactured by heating their oxides, maybe RO or TO with carbon. So it is like least reactive compared to Z. So Z is more reactive than R and T. In R and T we discussed R is greater than T. Then X is the least because that is in the uncombined format. I hope that is clear. So the right answer is going to be F. Z is greater than R is greater than T is greater than X. Next question, propene is an alkene. I mean, it's a double bonded unsaturated alkene. The structural formula of propene is shown. CH3, CH double bond, CH2. A polymer can be made from propene. What is the correct structural formula of this polymer? Understand, whenever you are making a polymer, the double bond will break into single bond. So double bond broken into single bond. You are having two hydrogens there, and here you are having only one hydrogen. Okay, and you will be getting one bond here and one bond here. And this is towards upside CH3 n times. So if you are checking this answer here, that is going to be C, H, H, CH3 up and H down. D is going to be the right answer. First one is wrong because you don't have a CH3 here. Second one, there is a double bond. You should not have a double bond in a polymer. Okay. I mean, after polymerization, this double bond is going to break. So you will not be having double bond in this polymer. The right answer is D. The next question, the compound BrCl and Bri melt at negative 66 degrees centigrade and 42 degrees centigrade respectively. What is the best explanation for this difference in melting points? The first statement, Bri covalent bond is stronger than BrCl covalent bond. Bromine iodine is having a covalent bond. In the same way, bromine chlorine is also having a covalent bond. No doubt in that. But they're asking you for the best explanation. Okay, it's not simply the explanation, the best explanation. Chlorine is more reactive, that is true, than iodine. So chlorine breaks away from bromine more readily than iodine. But that reactivity does not have any relation with the melting point. Melting point is actually related with the strength of the molecular bond. The forces between Bri molecule are stronger than the forces between BrCl molecule. They are not only having the covalent bond, there might be some another weak van der Waals forces as well. That's why we have to include the entire forces between the Bri and BrCl. That's why the forces between Bri molecule are stronger than the force between BrCl molecule. That's going to be the best explanation. The next D and E also will discuss. Iodide ions are larger than chloride ions, so bromide ion forms stronger ionic. It's not ionic. There is no ionic bond because bromine and chlorine are non-metal. They are preferred to form covalent bond, not ionic bond. Iodine atoms are larger than chlorine atoms. That's true. So the Bri giant covalent. It's not giant covalent. It is simple molecular. Okay, giant for silicon atom basically, silicon. It's not silicon, it's bromine and chlorine here and bromine and iodine here. So the answer is going to be C. 26th question, diammonium hydrogen phosphate is acting as a fertilizer, used as a fertilizer. The synthesis equation is given: 2NH3 gas plus H3PO4 aqueous is giving you NH4 2HPO4 solid. They are asking you the question, what is the mass of diammonium hydrogen phosphate that is produced when 3.4 kilogram of ammonia is reacted with phosphoric acid H3PO4 in excess? Understand the yield is not 100%, it is 80%, that is important. So 2NH3 mass is 2 times 17 gram. The MR values are given 17. NH4 2HPO4 is 132. So we can say 34 grams of ammonia is giving you 132 gram. So they are asking you 3.4 kilograms. So we are converting that into gram because every unit should be similar. So it's going to be how much? That is going to be, if you are using the cross multiplication logic, 3.4 multiplied by 1000 multiplied by 132 over 34. So you can write this 34 times 100 times 132 divided by 34. So they will get divided each other. The answer 130 to 100 gram. So if you are converting that into kilogram, it will become divided by 1000. So it is 13.2 kilogram. But understand that is also there in the option, but that is 100% yield. They are asking only 80%. So you have to calculate 0.8 of 13.2. It is going to be less than 13.2, not greater than. So all these values are greater than 13.2, say they are not the answer. So first one 5.28. So it is not 80% of 13.2. 50% is just half. It is less than half the 5.28. The answer is going to be 10.6. Even you don't need to calculate, you can simply remove the unwanted, I mean the old options out. So it's the 10.6 kilogram is going to be the answer. So that's all in this 2020 BMAT chemistry question paper. I hope it's clear. And if you like this video, try to share among your friends, those who are trying to prepare for BMAT, and all the best for you guys.